Okay, let's talk about the biconditional or the logical equivalence. We have our two statements, the princess bald and the queen is crazy. And a biconditional or logical equivalence is saying if and only if. So if and only if, which is typically written IFF. This symbol, which is called the triple bar, is what we're using to symbolize the P if and only if Q statement. Sometimes you'll see it written P if and only if Q. And notice here we have the arrow that goes in both directions. What this means is we've got P if Q and Q if P. What that means essentially is that the biconditional breaks down to a conjunction. Listen very carefully and you'll hear the conjunction. P if and only if Q. That means we've got this statement, if P then Q, and if Q then P. Notice we've already talked about the conjunction when we're looking at the truth value of the biconditional statement. How do we derive that? We've already looked at the truth value of a conjunction, and we know that a conjunction is only going to be true when both conjuncts are true. But notice each of the individual conjuncts is a conditional statement on its own, and we've already talked about the fact that a conditional statement is false when the antecedent is true and the consequent is false. So notice what that means. That means if P and Q have opposing truth values, if one of them is true and the other is false, and we have a conjunction here that's only going to be true when both conjuncts are true, and on this side we've got if P then Q, on this side we've got if Q then P, if they have opposing truth values, then on one of these two sides we're going to end up with the condition of having a true antecedent and a false consequent. That means on one of these two sides we're going to end up with a false. So the rule for the logical equivalence is this. A logical equivalence will be true when P and Q have the same truth values. If they're both true, then we have the impossibility of having a true antecedent and false consequent with either of these conjuncts. So ultimately the whole statement must be true, or when they're both false. If they're both false, then we have the impossibility of having a true antecedent and a false consequent on either side. That means that these conditional statements would both be true. That means the conjunction would be true. So the rule for the biconditional is a biconditional will be true when its constitutive statements always have the same truth value.